Hi everyone, this video is on exercise 13D question 1, and in this video I'm going to do parts A and C. So far we have been working with indefinite integrals, and now we have definite integrals. So the difference between indefinite and definite integral is basically indefinite integrals, like the previous examples we had, they always produce a function. So like for example, this integral that 10 minus 5t, the final answer is a function, 10t minus 5 over 2t squared. But definite integrals produce a value at the end. So they give us a number, maybe 10, 11. And so as you can see, that's because of these two limits. So this is the upper limit, this is the lower limit. So how do we solve definite integrals? It's very similar to indefinite integrals, with the difference that we just have one additional step. So first, we just integrate as usual. So x cubed integrates to 1 over 4 x to the power of 4. But the difference is that we no longer, write the constant of integration and a stop. But instead of that, we can use square brackets. So put the value of the integral, the function, inside a square bracket, and then write the limits, and then we just substitute the limit. So it's always the upper limit substituted minus the lower limit substituted, and that basically gives us the value of the integration. So first, it is 1/4 x, we substitute 5, 1/4 times 5 to the power of 4 minus, it is always minus, 1 over 4 times 2 to the power of 4. And that's basically it. So this is how we solve definite integral to find a value. And if we solve this, we are going to get 609 over 4. Okay, now let's do part C. We want to integrate root x between 0 and 4. By the way, in case you are curious, what is this value? What's the physical meaning of that? First of all, in the next few sections, which are about area under the curve, we are going to talk about this more. But essentially, this value is the net area between the curve and the limits of on the x-axis. So yeah, later on we are going to solve a lot of questions about this, but yeah, just a very brief explanation of this value. Okay, again, we want to integrate this. So we can rewrite this in the form x to the power of n. So it becomes x to the power of half dx. Okay, now we want to integrate this. So we always, when it's a definite integral, we open a square bracket, and so it is equal to 2 over 3 x to the power of 3 over 2 when it's integrated, and the limits are 4 and 0. Now we just substitute. So we have 2 over 3 times 4 to the power of 3 over 2 minus, it's always minus. The next term is basically 0. 2 over 3 times 0 to the power of 3 over 2, so it's just 0. And the answer now is 16 over 3. Yeah, so when you solve these sorts of integrals, it's very common to get some fractions that they don't look particularly nice. So but yeah, that's just natural. So don't think that you might have done something wrong, that you have got this strange number. And also another thing is that you can also use your calculator. And in fact, when you use your calculator and you put the integral with the limits, that indeed gives you the value of the definite integral. But the thing is, in the exam, if you have a question and they ask you to solve this, they want to see your solution. So make sure you write down your solution. But you can always use your calculator to check the value. Yeah, so that's it for this video. Thank you for watching.